Hey everybody, today I'm going to do a response video to one of my viewers who asked actually a really good question on my adaptive evens and odds video. And the question is that in my adaptive evens and odds game, I always assign the player to be evens, right? So the user is always even. But what if you wanted to allow them to be even or odd and give them the choice? How would that change the game, right? And at first it seemed kind of simple, and it's just using like a Boolean to decide to mark whether or not they chose even or odd, and then change your choices there. But when I thought about it a little more, there's actually a little more that has to go on in order to make this work properly. It's not super complicated, but there are actually a few considerations that you have to do. So let's go through it, and let's go and adapt this or change this here. So the first thing we're going to do is we're going to say int player choice is equal to 0, and this is going to be whether the player chose to be even or odd. All right, so right after we show the round here and the information, we're going to add in a part here that says system.println 0 for evens. Now, it seems odd that I would choose 0 for evens, but there is actually a reason why I'm going to do that. Okay, and system.println 1 for odds. All right, then I'm going to say system.println. Let's see, please choose evens or odds. All right, so, and then we'll say, and I don't want a print line. I usually like these to be printed on the same line. And then I'll say player choice is equal to input dot next int. Right, so the player is going to choose either 1 or 0, or 0 or 1 for, so 0 for evens, 1 for odds. Then here it always says you are the evens player, so I'm just going to put an if statement here. I'm going to say if player choice was equal to 0, then they are the evens players. Otherwise, actually, I don't even need that. I could just actually copy this line. And otherwise, they are the odds player. Now, technically, this should be error trapped, but I'm just not going to do that because I'm lazy. To do error trap the above input. All right, so now here what we're going to do is, this is just the error trap to choose to get the person to input their choice of 1 to 5. This section here is just getting the computer to choose its number. So let's skip that for now. What we're going to say here is look down here to the win condition, right? So if the computer's number plus the player's number is even, then you win because you're always even in the original game. So what we're going to do is just change this and just say player choice, right? So if the player chose to be even, right, then that was choice 0, right? So then the player choice is 0, and then you win, right? Because it's 0, right? Like it's even. If it's 1, when we checked if it's modulus 1, then it would have been odds if the player chose odds. And that's why I chose 0 and 1 instead of 1 and 2, because it just matches up well with this equation. All right, so let's actually give it a try here and see how it looks. So evens or odds. I'll choose evens. In this case, I'm the evens player. I chose 3. The computer chose 5, and I lost because it was odd. Okay, so I'm going to choose odds again, or I'll choose evens. Okay, so and let's choose 5 again. I'll choose 3 again. All right, let's go 0, evens, 3. Eventually, I should win. Yeah. Okay, so computer chose 1, the sum is 4, so I win. And so you can see this is actually working, and it actually coincides well with the menu choice number, right, to be either 0 or 1, depending on what they chose, like what the player chose, and it actually works well with this equation. So the next step is, well, how do you do the adapting? right? So the adapting is not actually as simple as it was. So this section here is I should just label this here, player's input, right? So this is the end of player's input. All right, this section here is beginning of adaptive algorithm. Okay, and down here is the end of the adaptive algorithm. Okay, then down here is checking the win condition, and here's the actual adaptation that happens, but this actually doesn't matter. Okay, so what this even threshold does is it checks whether or not the player tends to choose even or odd. Right, so here we're checking if the player's number was even, then the even threshold goes down. And so what we're going to do here is, because we're not always even, we're just going to say it's going to go up by 2. And the odds threshold or the even threshold will go down if they chose odds. So basically, now what we're doing is we're just saying how often does this player choose an even number versus an odd number. Right. Instead, now it's the reason why we need to check that is because the player can choose to be even or odd in this case, and so the choice up here, the sort of AI part, needs to be slightly different. So the question is, how is it going to be different? Now, what I like to do is, sometimes when I'm not sure about how like certain decision making would happen, is I write out both the decisions explicitly, and then I see the commonalities between them, and then see if I can actually make it a little more efficient and kind of tighten up the code, so to speak. So what we have is we're working with this even threshold, and the even threshold is basically an indication of how often the player chooses to be even or odd. Right, so as we changed it up down here, is that when they choose even numbers, the even threshold goes up, and as they choose odd, the even threshold goes down. Right, so the higher it is, the more likely it is indicating that the player is choosing even numbers. Okay, so let's take a look. So we're going to choose even or odd is equal to some random number, basically. Okay, so actually don't even need that right now. Let's just start from scratch here. Okay, so let's say, for instance, how would we do this if the player's choice was equal to 0? So the player chose even. Okay, so how would that change anything? Okay, well, what would we do? Okay, so what I would do is I would say, okay, well, basically we're choosing like what are the odds that we're going to win and what are the odds that we're going to lose. And so if they chose even, I would look at the even threshold, and I would say, well, if they chose even more often, then I would choose an odd number more often. Right. So what I'm going to do is I'm going to say, look at this even or odd threshold. Actually, it's almost the same. So let's take this. I'll just put it up here. And this is just a random number. And I'm just going to say, well, actually, almost all of this is going to be identical. If even or odd is less than the even threshold, okay, this means that I know that very likely they are going to choose to be, let's say the even threshold was 80. Okay, this means they very often choose even numbers. Right, so this number is very likely going to be underneath that threshold, which means I want to choose the odd number. All right, and actually, pretty much all of this is the same. So else, otherwise, we generate an even number. Okay, so that actually kind of makes sense, right? I hope so, anyways. So we have even or odd is we generate a random number, and we just basically look to say how often do they come up with even numbers. Now, if the numbers are even, then if they come up with even numbers a lot, then even or odd will be more likely under here, and we generate an odd number at random, of course. And then otherwise, we generate an even number. Okay, that actually is the same as before. And it kind of makes sense because before we always chose that the player would be even. Okay, but how does it change if the player choice was equal to 1? Okay, so the player chose to be odd. All right, so what if the player chose to be odd? Okay, so what we do is again, I'll kind of tighten this up later if possible. I actually haven't worked through a solution previously, so this is my first time looking at this. So what we're going to do is we're going to say, we're still going to calculate the even or odds. All right. Then what we're going to do is we're going to say, well, how does this change anything? So if even or odd is less than okay, so let's take a look. The even threshold now is, let's say the even threshold was 80. So again, very high. This means that they tend to choose even numbers, but they chose to win with odds. So if we want to, basically, this means that we're going to choose to win, and this means that the computer is going to choose to lose. Right? So how do we actually deal with that? So now this means the even or odd, or the even threshold indicates whether or not the person how likely the person will be to choose an odd number or an even number. The higher it is, the more likely they are to choose an even number. Now, if they chose odd, the first one is the win condition. So what we want to do is we actually want to produce, okay, this same thing. But what we want to do is we want to keep on producing numbers until it's as long as it's even. Okay, because the first one is if we chose to basically win. Right? So this one is basically, again, if we choose to win. And then the second one, the else statement, is if we chose to lose. All right. Now, if we chose to lose, then you're going to choose 1. Now, it's not necessarily a win or lose that we're going to take. Either we're going to take the best odds or the worst odds. And you can see, actually, that the real difference is only in a couple of ones and zeros. Right? So we have here, this player choice actually doesn't even seem to really matter if it's 0 or 1. This is just switched here. So there's a 1 here and a 0 here and a 0 here and a 1 here. Do we still do this even or odd? So this is the same. And so actually, the only difference is that in here it's a 1 and here it's a 0. But if you consider my earlier choice, with the player choice being 0 or 1, what we can say is, look, this first one, or the second one, actually always says, is the computer's number modulus 2 always equal to the player choice? Right? So here, player choice is 0, and so all I've done is just replace that 0 with player choice. In this else branch, we have player choice is equal to 1, so I'm going to replace this with player choice. Now, up here, we have 0, and so how do we deal with this? Right? Well, we can say, because the player choice is either 1 or 0, and it should be error trapped, as I said earlier, we can say not player choice. And here I can also say is not player choice. And so when we look at this, we have, if the player choice is equal to 0, we have this algorithm. But this algorithm is actually exactly the same as the one below it, meaning it is both branches do the same thing, which means that it's not required. Right? So it's not required to be a branch, and we can actually just go back to having just one section like that. All right, so one section adapting. This is the adaptive choice. All right, so beginning of the adaptive choice. So we generate a number, we check the even threshold, and then what we do is we just say, look, if they tend to choose even, so if they're tending to choose even, what we want to do is we want to make a decision based on the player's choice to be even or odd, right? And same thing here. Okay, so what I'd like to do here is just do some testing here. And I'm going to go up here and just put in some test code. Now I could use the debugger for this, but I'm not going to, just because I'm a little bit lazy. So I'm going to say system.println, and I just want to know what was the even threshold. Threshold even threshold. Okay, and then I also want to print out what the computer's even or odd number was. All right, so let's just see here. Even or odd number. So I just want to see how the computer's decision making is going. All right, so let's run this. Okay, so the even threshold is 50. If the player chooses to play odds, that actually should not affect the evens threshold. But let's say I choose 2. This means that the even threshold should go up to 52. All right, so you can see the even threshold went to 52. The computer's even or odd number was 42. So that means that they will choose. The computer chose. Let's see. So they were below the threshold. All right. So let's take a look. So the even or odd number was below the threshold, which means that they are going to choose to basically play the odds. Right. So. And in this case, it's 50-50. So they are going to try and choose something that has a modulus of the player's choice, and the player's choice was 1. So they are going to choose an odd number. And so you can see the computer chose an odd number 3, so the sum was 5, and then they end up winning, right? So that actually, and this actually kind of makes sense here, in that as the players continues to choose even numbers again. So let's say I go odds again, and I choose evens. All right, so an even number. The computer chose 4, sum was 6. Okay, so in this case, the number was 86. So meaning that they went to the second one, in which case they are choosing, let's see, it was, so what it is they chose numbers 86. So they're going to go into here and they're going to choose something that is the player's choice. So they're going to choose an even number. So yeah, I think it is working here. And yeah, that's basically how I would do this. So anyways, if you have any questions or if you have a better way to do this, then please put it into the comments. Remember to like and subscribe, and thanks for watching. I'll see you next video.